So yesterday we have seen how to read the beam rebars from the table. But anyway, I want to explain further clearly on that actually. You know how to make the beam rebars manually. That is making the beams and then using the side label command, we can fill the rebar information for the beams. But if you want to read from the table, so yesterday I showed you some table. Uh, so maybe if the rebar table is something like this, then I said we can easily read from this. So how the software actually working? So if I'm making any beams here, if I'm making any beam rectangular beam, then if it is a simple beam, I can fill the rebar information here. Some top 3T 20 plus 2T 10 like that. Again here bottom I can set it like this. If it is a simple beam, but if you're having a beam rebar something like that, then really how the software is working. So if you see here in the draw menu, that beam schedule. So here only actually it's writing actually. When I'm reading from, I'm trying to input all this information, whatever you're seeing no, here. All this information, the software is trying to input to store at this location. So this is the identify part. Through the identify part only, we are identifying from the 2D drawing, even including the schedule if I'm reading. So once I read the schedule, the software trying to put all the beam information into this this beam schedule. So even if you want to manually, if you want to make the beam schedule, you can make manually also here, and you can link with the model. That is also possible. That is what actually really happening. So if you see here in the drawing, so for example, PB1, this is PB1, 230 by 600. This is PB2, again 300 by 600. PB3, 300 by 600. So like this, PB4, PB5, PB6, like that it's going on up to PB6. So if you see here, PB1 alone is a 230 by 600, rest everything 300 by 600. Again, the last is 230 by 600. So manually, if you want to make, you know how to make manually using side level command. But here, if I'm reading from the schedule here, you can say PB1 and PB6, 230 by 450. PB2 is 300 by 600. So rebars, they mentioned like this. So this only, yesterday we tried to read actually the bottom reinforcement and this reinforcement. So manually also, if I fill it in the schedule, manually also if I want to fill it in the schedule, I can fill it actually. Instead of reading from the schedule, I can fill it directly here. I can go here, I can make new beam, new rectangular beam. I can rename it as PB1. Then how many spans it has got. So new span. What is the size of the beam? The size of the beam is 230 by 450, I think. 230 by 450, PB1. PB2, PB3, the rest everything up to PB5, it is a 300 by 600. So I can go here, I can give copy command. Even rebars also, if you want to fill, I can fill the rebars here. What is the PB1 rebars? PB1 rebars is the top, if you see 216 continuing and 212 is at the support in the bottom. So that means 216 to 12. So here bottom rebars, middle 2T16 slash. If you want in different layer, better you put slash 2T12 middle. So in the top 2T16, okay, the top 2T16 at the middle. So additional 2T16 at the support. So what I will do, I will go here 2T16, 2T16, 2T16 slash 2T16. I'll put it here. So this is what they mentioned here. So this same 2T16 will be continuing here, left and right. And middle extra 2T toll is there here for the bottom. No, for the bottom actually, so it is continuing everywhere, bottom, including 2T toll. So if that is the case, what we will do, we will copy this here. And then links. Links they mentioned as 200 center to center and 150 at the support. So links I can set it here, left. T8 at 200 center to center. And then 150 center to center. Okay. So the same rebars. So this is PB1. So here I have the copy command PB2. So PB2 is dimension is 300 by 600. 300 by 600. Again rebars. If you see here, the rebars are the PB2 316, 316 here 3T20. The top line person only at the right. 2T16 is extra. So 3T16. So this is at the bottom. So 3T16. 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 Okay, this will only let me change it. 3T20. 3T20 plus 2T16 extra plus 2T16 is extra, or I can make it slash. So like this, we can keep on. Maybe let me copy the same rebus just to explain you. PP3, PP4, PP5, and then this one is PP6, that rebar. So we are, so what actually the software is doing. So this I manually created. Instead of manually creating it, yesterday what I did, I read from the schedule. So what software has done, it has filled here all those rebar information. It has filled here. So after filling into this location only, so maybe if you want to export this rebars and then if you want to reuse it, you can reuse it actually. If you want to export and import, then what we have done, we have clicked generate element. So the rebar, so when I click the generate element, these beams will be created. Generate element, you can see here. So we just made some 6 beams, and then we have made the rebar, including the rebars. It is done now, but the rebars you cannot see here. Either in the attribute data you can see because it has come from the beam schedule. Okay, now where is our plinth beam layout? So here plinth beam layout is there. Plinth beam layout. So now I am going to identify. So how to identify? Identify the beam, pick sideline, the beam sideline, pick label, then auto identify. All the beams will be identified. You can see all the beams are identified with the dimension, whatever they mentioned, but other beams will not be having the rebars. Only the first 6 beams will be having the rebar information. That too, that is present in the schedule, not here. It is there in the beam schedule. So how to take this beam rebars into our model. So what I can do here, that's what did yesterday. When I click sync beam info, so syncing beam schedule info to into entity. Entity means the 3D model. So whatever beam elements we have, all those informations will be synced into entity. This is if I am selecting this one. So syncing element info to beam schedule. That means if I am changing the beam dimension in the element, only that will be updated into this schedule, the background beam schedule. But anyway, there is not, we will not use much here. Only this one, the rebars sync beam schedule info to entity. Whatever beam schedule is, the rebar information is there, that is should be synced into our entity. When I click OK, so you can see, let us calculate and see. Okay. So if I see the rebar 3D, it's not come. PB1 hyphen. Okay, it has created a new beam. It's supposed to overwrite. Okay, let me check. PB, PB hyphen 1. Okay, PB1. Okay, here it is created. PB1, and then 2. Okay, quick, quick select entity. 230 by 600. Oh, okay. The dimension were not given correctly. Actually, it's 230 by 600. We are given 230 by 450. Okay. Let me delete this. PB1, quick select, delete. PB2, otherwise we can batch selection. PB3, PB6, PB2, PB4, PB5. This is for selecting the entities. When I click OK, it will be selected. Then I can delete it. So here the elements also can be deleted. Elements are also deleted. Okay, actually this PB1, it should be PB1. That means in the schedule, we are not given the dimension correctly. The PB2, this is 230, not 230 by PB1, 230 by 450, 230 by 450. Oh, see in the schedule they are given some dimension, and in the layout they are given some dimension. That is another issue. 230 by 600. This is 230 by 600. Okay. So let us make it into 230 by 600. And this is 300 by 600, 300 by 600. 300 by 600. Sorry, 230 by 600. 230 by 600. PP1, PP2, PP3, 300 by 600, 230 by 600. Okay, let me generate the element from here. PP3, PP5. Generate element. There exists the same name, same type. Click X to overwrite. Yes. Okay. So PP1. PP1 dimension is again the PP1. PP1 is 230 by 600. 300 by 600. By 600. And now we need to identify the sideline. So now I'm going to identify the sideline. Pick sideline. Okay, already we are done. Pick label also already done. So now again auto identify. Okay. So beam schedule. Beam schedule. Sync beam info. Yeah. So the rebar information is filled from the beam schedule. Okay. So what I want to explain again here is the main purpose of reading the schedule. So when we read the schedule, so what is happening is when we read the schedule, the software is reading the rebar information and then it's keeping it at the beam schedule location. Then when we are identifying the side label, then the beam 3D will be made. After that, we need to enter into here and we need to sync beam info into that is a rebar information into the model. So we need to do this. So that's what really it's happening in the beam identification. Okay, I will show you the real procedure. What I will do, let me select all the beams and delete it, and then I can select all the beams, shift, delete it.
Sir, one doubt.
Yeah,
We can't able to identify this schedule.
we can identify yesterday. That's what actually I explained you how to read from the schedule yesterday. So
Okay,
the
okay.
same thing, same
Same
thing.
thing as
So what is really
had.
happening? I just explained. I'm going to read from the schedule again for you. Okay,
Okay, okay,
this I did
okay.
manually. No, this I did manually. No, just now.
Okay, sir.
Yeah.
Okay.
So really, what is happening? Just I explained.
Mm.
Okay, this what software is doing. I will delete this one. I will delete all the beams. Deleted. So actually what software is doing, so automatically when you're reading this principal entire rebar information, if I'm reading, the software, what it does, it is taking that all the rebar information and then keeping into beam schedule location first here. Then what we are doing, after getting here, we are generating the element here. From here, we are generating the element. Then all the beam element will be generated with the rebars. But entity will not be ready. So after that only what we are doing, we are going here, we are doing identify beam command. Okay. So let me send back the restore CAD entity also. I will repeat again how automatically we need to read. Now we will get some better understanding. Okay. So what we will do, we need to go to the identify and then we need to read from the schedule, clean the beam rebar table. So this is the clean the beam rebar table. Yesterday what I showed you. So we are going to read from here. So when we read from here, what it will do, it will copy those information into beam schedule. It will do now. I will select identify schedule. I will select the entire table. Right click. So this is what yesterday we have done. So when we do, we need to set the heading correctly. This is the beam. This is the width. Actually here, that's what actually drawing and there is a mismatch actually. This is 230 by 600. Just now we have seen. This is 230 by 600. Okay. Width. This is the height. Because this is the bottom rebars, the left hand side. Bottom rebar, bottom middle layer, bottom right support. Again top rebars. Top rebar left, top middle, top right. So this is links, left densified link. This is middle link. This is right densified link. Okay. So we have set it this and maybe this three we can delete. Delete the row. And then okay, these ones are not required. And here as I told you, this PP1 this should be separated. So what we can do, insert row. I can copy. You can paste this here. Then you change it as this is PP1 and this is PP6. Otherwise, it will take it as a single name. So this is 230 by 600. So here they mentioned as 230 by 600. Okay. Yeah, it is done now. So if there is any error, it will pop up now. See here only, as I said no just now, generate in beam schedule. So first we need to click this one. We should not generate element. First we should take it into the beam schedule. Generate in beam schedule. So when I click generate in beam schedule, if there is any error, it will pop up. Generate in beam schedule I am giving. As I yesterday told you, that is C/C and all, it was not taking. So what I can do, I'll just find and replace. So wherever C/C is there, replace with empty. And then wherever this 2L hyphen, replace with the empty. Even this hyphen also it was not taking. So hyphen, it takes only 2T16 like that. So hyphen also I'm removing, all removed. So now it is, now it can take. So what I can do, again I'm going to click generate in beam schedule. All this information will be taken into beam schedule. See, identification finished. Enter beam schedule to view the identified element. Yes. So this is the beam schedule it has created. Actually, maybe this the background one dialog is done, that you can close even. Okay, so this is the beam schedule has come. So from this beam schedule, I am generating the element. So element means beam elements. You know what is element, beam element. When I click generate element, you see all the beam elements are generated. I can close it now. All these beam elements are generated. So from where it has come? From this beam schedule only. So how it has come? So whatever we have read now, the table, it has written automatically the entire beam schedule. Maybe for the, maybe if you want to save it as a file, you can save it as a file. At any time you can import it. Maybe locally you can modify here. And then again, if you click generate element, it will be updated. Sync beam info, it will be updated. That's what happening inside the software. That's what I just now explained. Okay, just element alone we have done now. So entity is not yet done. So how to make the entity? I will go to the plinth beam layout. I need to read the identify menu, identify beam, pick sideline. This is my beam sideline. Pick label. This is my beam label. So when I say auto identify, the beams are done, but it's shown in this color. That means rebar is not done. So in order to get the rebar, what we have to do? I should go to the draw. I should go to the beam schedule. There is a sync button. I am going to sync all the rebar information into entity. Okay. Yeah. Now it is changed into green. This is what really happening. I'll go to the quantity, calculate. Maybe if you practice this procedure, I think once if you have practiced with 2 or 3 times, then you will be knowing how the software is working. You see, the beams rebars has come. So for some beam, maybe we can check and can solve it. But till actually say all these beams, each and every span they have given. B1, B2, sorry, BB1, BB2, BB3 like that. But some beams may be continuous beams. So how to make as a continuous beam? I told you after identification, you need to select like this. If you think this is a continuous beam, you need to select like this. Right click. There is a merge element and entity. You need to give this command. Whatever beams you want to make it as a continuous beam, give the section of each segment entity. So it will be made as a continuous beam. So the problem is section sizes is different. So you have to make it like this. Okay, we are not calculated again. So understood how the software is working.
Yes,
So
sir.
yeah, when you read from the schedule, so it is making a locally it is making one beam schedule. So whatever you are identifying, it is maintaining at this location. Then what you are doing? You are doing the identifying from there. You are generating the elements from here. From here, you are generating the elements first. After that, what you are doing? You are doing the side label command. Sorry. After that, what you are doing? You are identifying the beam, that is entity, from using the sideline command. Then what it's doing? It's comparing the beam sizes, beam label with whatever element you generated from the beam schedule, and then it will match with that. After that, what you are doing, you are syncing the rebar information here. You are syncing the rebar information into entity. When you click OK, then automatically the colors changes into green color. At the time, it will take all the support conditions, everything automatically. Then when you calculate, you will get the rebars. If you think certain beams are continuous, then you need to select those beams and then right click. There will be a merge element and entity so that it will become a continuous beam. So this is what you have to do. So yesterday, this is what I have done. So again, I explained to you how the software is taking the rebars from the schedule. Okay. Okay. Like this, maybe we can make the rebars from the schedule. But sometimes if we have the rebars in this type of drawings, then and also the drawing also may not be to the scale. So what you have to do, you need to each and every rebar, you need to read actually. If you're having the rebar drawings, something like this. So how to read? So what we can do, check. So those type of, see, after making the model like this, maybe without rebar, you know how to make the model without rebar. So straight away you can go here. When you click identify beam, the model will be ready. Then after that, maybe you can select a particular beam, and then when you go to quantity, there is a rebar layout. When I select a rebar layout command, it will pop up a window like this. So here only we can do reading from the 2D drawing. So it will show which beam you are doing. Maybe you can select it like this. But when you are reading in this type of drawings, you will not get the rebars in 3D. Only the quantity alone you will get. So how to import the drawing here and how to read it? So here there is a add drawing command. So beam drawings, I'm selecting a beam drawing. I have imported now. For example, this is the beam drawing. Let me assume this is the beam, what I'm going to read. So how to read this B1, B2, B3 like that each rebar. Again here hyphen and all they are using. Let me check whether I'm getting any problem. So identify main bar. So here mostly I will be using only these two commands. Identify main bar, identify links. That's all. So identify main bar. I'm selecting. At the bottom you can see what is the help you are getting. Click to select a main bar info. Right click to confirm at the bottom. So I'm going to select this is my main bar info. Selecting it, right click. They cannot be identified. The reason the hyphen it is not taking. So what I will do, I need to remove the hyphen from this drawing. So here we have find and replace. Wherever hyphens are there, replace all with the empty. So now it is changed. The software reads only 2T16. Okay, again I will go here, identify main bar. So it says click to select main bar info, right click to confirm at the bottom. Okay, this is my main bar. Right click. Then it says click to select CAD line, right click to confirm. I'm saying this is my rebar line. Right click. Then from anchorage, from where and where it starts the anchorage. From this intersection to this intersection. Right click. It will pop up a dialog like this. This is the rebar information, anchorage length, everything it shows. Even here also, if you want to modify, you can modify. Anyway, the drawing is not to the scale. That is why here 3000, but the span length is 3500. Okay, if you think 3500 is the correct one, you can modify 3500. So two numbers of T16. This is a top continuous bar. That's all. When I click confirm, the rebar will be generated like this. Again the same main bar. I need to follow again. This is the one. Right click, anchorage from here to here. Right click, whether this dimension is correct or not. No. Modify. Click confirm. Another rebar will be done. So like this, I can keep on identifying. I think this is 800. This also 800. Whatever dimension they mentioned, confirm. This will be done. So from anchorage from here to here. So again, this if you want to modify, this is 3500. Confirm. So like this, I should keep on read each and every rebar. Again for the links. So links how to read. So here we have identify links. So what it says, select link info, right click to confirm. This is the link info, right click. Then select section info. What is the BIM section size? This is the section info. Okay, then from where to where you want the links, from this point to this point. It will pop up a dialog. So the layout length is total 3000. Is this correct? No, because it is 3500 actually. So when I make 3500, the total number will be automatically calculated. When I click tab, that has become 19 total numbers. Okay, again, so bottom main bar they're asking, maybe I can read it from here. This 216 dia, and then all other things, hook length, number of legs, everything is showing. When I click OK, the links will be generated like this. Again, similarly for this. So select the link info. Link information is this one. And then section info. This is the section info. Then from where to where you want the links. From here to here. If I say the length, then this is 3500 tab. Then when I click OK, the link will be generated. So like this, we should keep on read each and every rebar. This is another method. If you have the detailed beam rebars, you have to read it. Maybe say maybe you can select whatever beam you are filling. For example, B2. If you are filling the B2, then maybe you need to come here. Wherever the B2 is there, you need to select. If this is B2, this is B2 like this, you can fill it. Then after that, when you click exit, to see actually we have selected this beam and we filled those information. So it will look like a locked symbol. It will not show in 3D also if you are calculating. I can go and I can calculate. Then the edit rebar. So whatever rebars we have filled there, all the rebars will be shown here. So this is how we have to make beam rebars if you have the detailed LS section like this. Otherwise, if you are having the schedule like this, then it is easier. Maybe you can make a schedule something like this after reading this type of drawing. And then you can fill directly into this location if required, beam schedule. Instead of reading from the schedule, if you don't have the schedule, you can straight away you can make the beam numbers, you can fill it. Then when you click the generate element, the elements will be generated. After that, again, you can follow the old procedure. You can select the sideline, identify the entity, sync the rebar information from the beam schedule to rebars, sorry, beams. Like this also you can do. Is that clear? Maybe if you want, I can share the drawing to you. this drawing, and then one more drawing for the stairs. This is beam drawing. This is stair drawing. Two D drawings to explore. So I shared both the drawings. Similarly for the staircase. For the staircase also, see staircase actually we cannot do here. For the staircase we should do only in the single element. See even for that under a lot of improvement actually currently they are making reading the drawings. So currently I will tell you how we can get it because some limitations are there for the reading the staircase. So here yesterday I told you for the staircase from the single element you have to do. So how to do the single element? Yesterday I told you you can go to the single element, you can make the add element, and then the parametric you can fill the rebar. You can predefine the stats, you can fill the rebars. That's what yesterday I told. But today if you want to fill it with the 2D drawing, I'll show you how to do it. Add drawing. So here when we add drawing, using add drawing command, start drawing, staircase 1. So for example, let us take only this staircase. So here also we have the split drawing command. Let me get the drawing. Yes. And double click staircase. You can check the scale. Distance. That is to the scale. Okay. So with the section marks they are shown. Section 1. This is section 1. So some limitations are there, but even with that limitations, we can read the star rebars from here. So how to read the star rebars? So I can go here, identify main bar. Then I'll go here. Select a main bar info, right click to confirm. This is main bar info, right click. Select CAD line. This is a CAD line. And then right click. Then we need to mention from where to where this particular rebar is required. So if you see here, the section is taken here. That means it is required from here to here. Then what I will do is it's asking from where to where. From here to here. When I right click, it is popping up. That layout range is 1625. That length. So for 1625 distance, this rebar is required. So automatically it's calculating number of rebars 14. So this dimension also maybe if you want to modify, you can modify. So 1625. So again confirm. So this rebar is identified. Again, now this rebar, the bottom rebar. Again, same procedure. Select main bar info, the rebar line. and then end point. Again, you need not to measure that. If you know the dimension, straight away you can mention the dimension 1625. Then numbers will be automatically calculated. When I click confirm, this bar will be generated. Then now this bar. Again, rebar, this. Again, this also same 1625, 625, 40 numbers, confirm. Again, so like this, you should keep on read. This is the main bar info. This is the rebar line. This also 1625. Confirm. So if we have the rebars like this, we can read it like this. Okay, then for the range, for the distributor bars, also again we need to read, but the problem here is we don't know the length actually, from where to where you want the length. Maybe we can read it here. So for example, for the distributor bar, we need the length, but generally for the distributor bar, they will not show in the plan. So what we can do, maybe I can do it like this. The length of the distributor bar. What I will do, here it is asking select the main bar info. So for example, the distributor bar info. This is the distributor bar info. Now I need to select the CAD line, but the CAD line is not given. So what I will do, I will take from here. Then from where to where you want this line. The distributor bar is from here to perpendicular is enabled. From here to here. Then it pops up with the length, and then layout range also, the numbers also is giving. Maybe if you want to modify with any cover directions like that, you can modify. Maybe 1550 or 75, confirm. So your distributor bar will be calculated. So like this, we have to make the rebars for the stairs. Is that clear? So this is how they have implemented for the staircase rebars. If you want to calculate, you have to calculate. You have to like this only. Otherwise, you can use the parametric method. Parametric is add element, parametric input. So any predefined stairs, you can directly fill the rebar information and get the rebars. When I double click, it will allow me to edit. After editing it, when I click generate rebar, stair to the rebars will come. So like this also we can. If you want to read from the 2D drawing, then you need to go to the identification, import your 2D drawing, then you can read it like this. Okay, can you do all this? First, maybe you can read from the beam drawing, and then you can do the stairs. I will explain again. So how to read? Okay, anyway, this one you understood. So how to read from the schedule? When you read from the schedule, that is when you read from the AutoCAD drawing schedule, all this rebar information using the identify schedule command, you can read it. Once if you read it, all those information will come into this location, beam schedule location. So once it has come to this beam schedule location, then from here you are generating the element. So once beam elements are generated, your beam elements will be here, all the beam elements. Then what you have to do, you should go to identify beam sideline command. You have to identify the sideline to make the entities. Then automatically software will take whatever beam names is given here, but wherever it's matching here, it will assign with that. But the rebars will not be input into that. To input the rebars, again you should go to draw. You need to select beam schedule. So there is a sync beam info command will be there. So when you click OK, so syncing beam schedule info into the entity. So entity you have done it. So you are syncing the rebar into entity. When you click OK, your rebars will be input into your beams. That is reading from the schedule. But if you want to read from the LS section of the beam rebars, then what you have to do? You should go to the quantity. You should go to the rebar layout. In the rebar layout, maybe you can select any one beam. So whatever beam, it will pop up the entire your model. So each beam wise, maybe you can select. Here they are given entire drawing B1, B2, B3 like that. Then maybe you can select each beam. This is B1, this is B2 like that. So how to read the rebars? So I explained you just now. The software was not taking that hyphen symbol. To remove that hyphen, what I have done, so find and replace here. I selected find and replace. Wherever hyphens are there, I just replace with the empty, replace all. So it removed all the hyphens. Then what I did, identify main bar command. So you need to select identify main bar command and follow the instruction at the bottom. Click to select main bar info, right click to confirm. So this is the main bar info. So right click, select CAD line. Where is the rebar line? This is the rebar line. Right click and then specify the anchorage from where to where you want to anchorage. From here to, from both ends we need anchorage. Right click, then it calculates the development length. Based on that, it shows the dimensions. Maybe if you want to modify, you can modify these values also. You can check whether this value is correct or not. But the given span length is 3500 because they have drawn not to the scale. So I'm modifying based on the table they have shown 3500. So when I click confirm, this will become 216 dia rebars. Again, command is continuing. Click another main bar info, right click to confirm. Again, this is also main bar. And then select the CAD line. This is also a CAD line. And then anchorage length from here to here. Right click. The anchorage length software automatically calculate and shows. Maybe if you want to modify, you can modify. This is 3500 span. When I click confirm, this rebar also will be done. So have you received my drawing? Are you able to work with my drawing? So like this, we should keep on select the main bus first. After that, links. So here we have identify link command. What it says, select link info at the bottom, right click to confirm. So link info is, this is the link info, T8 at 200, right click. Then it says, select section info. What is the section size? Section size is they given here, right click. Then from where to where you want the links. Specify the start point of layout area for links. I want from this intersection to in this intersection. So it will pop up a dialog like this. Here also, if you want to modify anything, dia or whatever, but mainly you need to modify this one because the length is not correct. So 3500. When I click tab, the number of links will be updated here. Even section width also, maybe if you want to modify anything, you can modify here. So bottom main bar, they're asking dia. Maybe I can use the read command. I can select from the here. So angles, everything they're showing. If everything is okay, then you can click OK. So links will be generated. Can you read like this? So each and every rebars you have to read. If you have the LS section of the rebars, beam rebars. But in our software, always it is easier if you're having the beam schedule, rebar schedule. Similarly, if you want to read here, I can go to the identify main bar. This is the main bar. This is the rebar line. Anchorage from here to here. Right click. By default, it shows 600, but they have shown 800 there. So you can modify here. 2500. Confirm. Then here, here, here to here, 3500. Then links. Identify links. So link info. This is link info. Section info. This is section info. And then from where to where? From this intersection to this intersection. Okay, again, this dimension. This dimension is here they have shown as okay, length actually we should have modified, I think. I think we are not modified. 1650. 1650. It will be calculating. When I click OK, the links will be generated. So I can exit. When I exit, it will come out like this. So wherever we have linked, the particular beam will be shown as like this. So actually for each and every beam, you need to fill the rebars like that. So that all the beams will become like this, locked. Then you can calculate and get the beam rebars. Okay, how to make the rebars for stair drawing. For the stair drawing, you have to read from the single element. So you need to go to the single element. You need to select the stair. Then you need to add element. Then you have to import your stair drawing just by adding here. Then you can split it whatever stair drawing you want. And then you need to read the rebars. So how to read the rebars? So identify the main bar command. So select identify main bar command. So follow the instruction. Click to select main bar info. Right click to confirm. So let us take this main bar first. Select CAD line. This is the line. From where to where? That is important. So that information we cannot get in the section. So there is nothing but from where to where is here, from here to here. So I can select from here to here. So 1625. So when I right click, it will pop up dialog like this. So for the 1625, 40 numbers is required. When I click confirm, the rebar will be done. Then next rebar. So this is the main rebar. This is the uh, rebar line. And then 1625 is the width I know. 1625. When I click tab, it will calculate the numbers. When I click confirm, this rebar will be generated. So like this, we should keep on read the rebar information. For the side rebars, sorry, for the distributors, for the distributor rebar, they may not have shown in the plan. So we have to read from the whatever existing length we have in the plan. So this is the distributor rebar. So how to read this one? Again, same command only. It's asking select main bar info. This is main bar info. Then it's asking CAD line. Rebar line is asking. Rebar line only section, circle only they shown. So from where to where it goes? Actually, it will be from here to here. This line, CAD line. So I'm making this as a rebar line. Right click. And then from where to where? The distributor is required from here to here. Now right click. So this is the length of the distributor bar. This is the layout range, whatever I have selected. Maybe this length also, if you want to modify, you can modify. When I confirm, the distributor bars will be done. So like this, we should identify each and every rebars if we have the star rebars. But these and all actually they keep on improving, but lot of improvement is required. But currently these are all the features available. With this only we can get the rebars quantities. Is that clear for anybody? Any doubt? I will go to the slab rebars now. So how to make the slab rebars? So now you understood how to make the beam rebars, how to make the stairs and the LS section of the beams. Okay, slab. So before making the slab, there should be a slab element. Slab 3D model should be there. So what I am going to do, I'm just going to make a slab. I'm going to make thickness is 125 mm. Draw using point command. Okay, slab is done. So for this, we need the rebars. So where is the slab rebars? So see, generally for the slab rebars, if you have the detailed slab rebar, but anyway, the manual method also very easy in our software. You know already how to make manually the slab rebars. I can go to the main rebar. I can select here the slab main rebar. I can make the main rebars. So using the single or continuous, whether horizontal, vertical, or both the directions, I can select the span. So rebars will be done immediately. So that is manually making rebars also easier only the software, but automatically reading from the 2D drawing. So I will go here, identify. So first I need to relocate my slab drawing. First floor. Okay, maybe I will not split the drawing. PVT bar. It's here. Bottom reinforcement. Layout and the first floor slab. Okay. First floor, first floor layout. So this is the rebar layout. Not rebar. First floor bottom rebars. Yeah, this is the rebar layout. So what we need this three information only for the slab actually. One is a rebar line, where is the rebar line, and another is a range line from where to where it goes, this particular rebar, and then the label. So all these three information should be in a unique layer. Only then it is easy to make rebars, slab rebars in our software. So I need to relocate this drawing. So for that we have relocate command, relocate. So either based on the grid or based on any column, I can relocate. So based on the column I'm taking, I relocate it. So I'm going to identify this rebus. How to identify? So when I am in the identify menu, here I will be having identify slab rebar. I should be in the I should be in the slab main bar in the left hand side, slab main bar component. You can see here. I should be in the slab main bar component, and then I should be in the identify menu, and then identify slab rebar command will be here. So when I click here, it will ask this information. But when you're identifying, no, first you select a rebar line, then don't select label, select a bar range, then select the label. You have to work like this only. So when I'm selecting the pick rebar line, so based on the layer, so select the rebar line. It says I'm going to select. This is my rebar line, pink color. So this is my rebar line, and then pick rebar range. So after rebar line, you select a rebar range. So when I'm selecting rebar range, this red color is my rebar range line. And while selecting, in the this dot also should be there. If this dot is not there, software will not identify. And also, so this dot also should be in the range line layer. And you should not use the drag window. You should use only this cursor, because only then at all the location this will be identified. So this is the range line, and then pick label. This is the label of the rebar. That's all. So all be identified. When I go and when I click auto identify, wherever labels they made, they placed, all the locations, rebar will be created. If anywhere slab rebar, if it is unlabeled or label is not there, so do you want to consider anything is asking. So maybe 8 die at 200 if you want to say, you can say. And I click OK, all the rebars will be done. So all are identified at all the locations. If there is any errors, no, then it will be there here. So only these 4 locations it does not place the rebar. So maybe we can check it actually. Or by mistake, even if you closed it, you can click here. Is there any errors? Yes, these errors are still there. Why it is not placed, we don't know. Maybe we need to check here. When I double click, it will take me to that location. You see here. This is the rebar line, but a range line, that circle is at some location and the line is at some other location. So there is a reason. Okay, then how to make the rebar? Only for this one, I will close it. So here in the draw menu, we have the commands. So this rebar I need to make T8 at 200, T8 at 200. Okay, you know how to make manually. So I will use the draw line to arrange. Draw line to arrange is setting the range for setting the range. I can use custom also, but anyway, this is easiest because first 2 points are range, another 2 points are rebar. So first 2 point is range. Range is from here to here. And then another 2 point is bar line. Bar line is they are shown from here to here. That's it. So this rebar is done. Then again, I need to check that rebar is done. Then this rebar. Again here. I think this rebar is here. This rebar, I don't know the range. They have not drawn the range at all for this line from where to where it goes. They have not drawn the range for this rebar. Okay, if range is not done, maybe if you want the rebar for particular distance, let us assume from only here to here, something like that, we can make it. So how to make it? I will go to the draw command, draw line to arrange. I will make from, for example, let me make assume from here to draw the range line. So from here to here somewhere, and then the rebar is from here to here. When I click, this bar will be done. So like this, we have to make it manually. Wherever the rebars are not placed, we need to make it manually. Again here, so I will select draw line command. First is a range line from here to here. Another one is a rebar line from here to here. Okay, another one is this one. First range line, another one is a rebar line. That's all. So like this, we need to solve all the location. Then when I click quantity, calculate. Okay. Uh, okay, all these bars are actually bottom rebars. It is taken as a top rebar. So what I will do, I can select all these rebar. Select, will select. Instead of top rebar, I will change it into bottom rebar. Not selected. Okay, select. Okay, so bottom rebar only. So it is changed into bottom rebar. If you want to delete, we can delete that label. So when I calculate, calculate. Okay, I see in rebar 3D. So entire slab will be done. So is that clear? How to read the slab rebars? For the slab rebars, the important thing is the detailed drawing should have all these three information. One is a rebar line, another one is a range line with a dot, another one is a label. These three should be in a unique layer. They cannot say something like this. Wherever one is there, T8 take T8 at 100 like that. So the label is secured near the rebar. Otherwise, see, maybe it's a manual method also it is easier. Manually, if you want to place, you can select slab and then using the commands, vertical or horizontal or both the direction, you can place the rebars for the slab. Okay, I will tell you again. So how to make the slab rebars? So first what you have to do, you need to import the drawing. Deleted the rebars. So first what you have to do, you need to import the drawing. Then you should go to identify. So when you are in the identify menu, so when you are in the slab main bar here, then you will see this command, identify slab rebar. When you click identify the slab rebar command, then it will ask you to select. The first one is pick rebar line command. So using the pick rebar line command, first you need to select the rebar line. The rebar line is red, red color line. You need to select and right click. Then pick rebar range. Select pick rebar range and then select the rebar range line, and then you need to select the small circle also. The small circle also you need to select. Then you select the rebar label. First select rebar line, rebar range, then rebar label. Select the rebar label. So after selecting it, when you click auto identify, so all the rebars will be done. This Tandai also has some locations wherever labels are not there. So if there is any errors, you can check it here. Identification check. So somewhere labels were not there, so it has taken Tandai. So we need to solve this. So you know how to make manually the rebars. How to make manually the ranges in case anywhere if range is not there. Go to draw and then use this command. Draw line to arrange. Take whatever die I want and then use draw line to arrange. First it will ask you to draw the range line. The bottom if you see. First it will ask you to draw the range line. Select 2 points. Then rebar line. Select the rebar line from where to where it goes, rebar. When you right click, then the rebar will be done wherever missing. Then just okay. So by default it is taking a top bar. Maybe I can make it as a bottom bar and we can calculate. If you want to see the quantities, you can see in the okay, each and every rebar if you want to see, you can see here. Edit rebar. Maybe here the report when you go, the entire quantity will be there. So already I explained you how to make the chair rebars for the slab. So chair rebars you need to make it in the slab element only. In the slab, when you go to the slab element, there is a bar chair. In the bar chair, you can include what type of bar chair you want, and then the dia you can mention it here. T10 at every 1 meter by 1 meter. Okay, this is a entity property. If I'm setting like this, it will not work. Okay, this is entity property. So for that, I need to select all the slab. Then I need to modify here. To know what is entity property and element property. So this entity property, then I need to go here. I need to select the entity. Then I need to set here T10 at 1000 by 1000, 1 meter by 1 meter. This dimension we need to give 300, and this is 450 or 600. This is thickness of slab is 125. After deducting the everything, maybe if you want to give 100, when you click OK, it will take. So when you calculate, number of chairs also will be calculated. Here total rebar summary. Here you can see the total rebar summaries. And then even in the single element, if you have some quantities, that also you can see, including single element quantities. Okay. Now we need to make the top bars. So for the top bars, again, they have another drawing here. Layout and implemented for slab top rebars. So how to make this top rebars? Again, we need to superimpose this drawing there. Slab, but the identification command they have only here, the slab main bar only, not in the support bars. So here I need to relocate the drawing. So relocate drawing based on this column. It's relocated. Now we need to identify the top rebar. Again for the top rebars, same command. Identify the slab rebar command. Pick rebar line. This is the rebar line. And then pick range line. This is the range line. And then pick rebar label. This is rebar label. Let's say auto identify. Is identified. Again, if any errors are there, you need to manually, you need to make the ranges there. I don't know, for this actually it is taking as a bottom bar. So maybe we can select quick find. and change it into top bar. But here currently the software has got a limitation here, the slab rebar identification, mainly the top bar. That limitation is if it is automatically identifying, then they are not making the distributor bar. So we have to make the distributor bar. Even distributor bar also, if it is shown in the drawing, it will be identified. If distributor bar is not shown, then we have to make it manually the distributor bars. But when you are doing the support bar, so you know how to make the support bar already. I explained you. So when you are going and when you are doing manually the support bar, so I can go here, I can make any support bar manually, like one support bar, and then the support bar dia, I can set it here. Here in the distribution bar, I can set here. When you make manually, then I can set the distribution bar here itself before making. So by L by 3 length, it will automatically it will take. But here when they're giving the drawing like this, then it is not that always they'll be giving L by 3. Whatever dimension they are showing, that dimension we need to take. But the software is giving L by 3. But when you're making manually, you can modify this dimension. But when you're reading, then software will take whatever length they have shown. So manually to make the rebar support bar, I can go here. I can make one support bar. So based on this condition, based on the beam, wall, slab edge, based on the beam, if you are making, can select the beam. That's it. Support bar will be done. So I can select, right click, calculate selected entity. So it is not only the support bar. Actually, the distributor bar also is done here, but it is not. They are not showing in the 3D. But a distributor bar also will get in the quantity. So when you're doing, then you are getting the distributor bar automatically. But when you're trying to get the rebars from the 2D drawing, then distributor bar also you have to make manually. So that is limitation in the software currently. So have you understood how to read the slab rebars? So just split the drawing and then, so already I have split the drawing here. So top rebar drawing, I just relocated the drawing using relocate command. So after relocation, we need to identify. So for that, automatically if you want to identify, then you should be you will not get the command here. In other locations, you will not get the command. You will get the command only when you are in the slab main bar. So when you are in the slab main bar, only then this identify slab rebar command will be there. So when you click this command, you can select first you need to select the rebar line. So you need to select the rebar line first. And then you need to select the range line from where to where. So you can select just this line and this dot also you need to select when you are picking the range. So first select a rebar line, then you select the range, then only you should select the label, this label. So after selecting it, when you click auto identify, then automatically all the rebars will be placed. But the big challenge in automatic method is anyway you have to ensure at all the location whether the rebar has come correctly as expected. If anywhere if it has not come or anywhere if any bend length anything is missing, you have to modify the attribute editor as per your requirement. That is the big challenge when you are doing automatic identification. But when you are doing manually the slab rebars, then you are sure that what is the rebar you are doing, what is the rebar you are selecting, what is the length you are making, everything it will be very clear to you. But making rebars also in 3D model is very easy. Manually making the rebars also in our software in comparing to any other software in the industry currently. In all other softwares, to get the rebar BBS, you have to make the 2D drawing. Only then you will get the rebar quantity. But in our software, if we have the schedule, from the schedule itself, software can read the rebars. So are you able to do the rebars for the slabs? I think we have completed actually. So maybe in the next class I can explain you with the model directly exported from TAS. The same model I can directly export from the TAS. I can directly read the rebars alone so that the rebars alone can be input into the model. So almost we have seen everything. For the lintels, I think, see, the lintel also same. So whoever has done the task, they'll be knowing how to make the lintels. So let me, so before that we should have the wall. So I should make the wall, you know how to make the wall. So I'm going to make a masonry wall of thickness 230 mm or 200 using rectangle command or any commands, either line command or whatever commands. Like this. Then we'll copy command, another masonry line, on 10 wall. Want to make, I can make function F4 for alignment. Okay. Then, so any doors and windows if you want to make, I can make doors and windows. Door. So doors and windows I can make like this. Maybe I can copy another door. Another door size is 900. The internal doors. And then I can make some window. Window dimension 1500 by 1200. So this is 600. If you want to place, you can place some windows. Copy command. This is 1000. 1000. Copy from 2200 anything. So we can make the openings like this. Then lintel if you're making, the lintel is same like task. So I can make a rectangular lintel. So whatever rebars you want to set, lintel depth. So lintel 1 is some 150 depth, two numbers of T12 and two numbers of 10 dia, and then 8 dia at 200, and then the supports 150 mm both the sides support. So like this we can fill the lintel rebars. I can copy, I can make the lintel depth is 200, maybe 3 numbers of T12 and 3 numbers of T10. So this lintel, if you want to apply to all the spans less than 1000, then here we have auto arrange command. So we will call this as auto arrange command. Already in task also it is there. So lintel 1 I'm going to place wherever the opening dimensions are 50 mm to 1000. And I click OK. So it will be placed. You can go and check wherever the opening space is less than equal to 1000, it is placed. So other lintel is 200 thick lintel. So what I will do, I will go to the same command. So wherever opening with this 1001 to 7000, I'm just saying any number. So because I'm sure there will not be any opening like that. So this lintel will be placed at all the location. This is cut lintel. If any continuous lintel, anything if you want to make, then maybe you can use either embedded beam command or directly the beam command. The simple rebars you can input into that, and using line command, you can make the continuous beam in the building. I think that's all almost we have completed. So tomorrow maybe I can explain how to read from how to input the rebars into already existing 3D model. For example, whatever model is made in task software, that model we can import it here, and straight away we can read the rebar information from the schedule and input into the model. So that also won't take much time. So maybe whatever doubt you have, you please practice it and then come out with your queries and we can clarify you. Maybe after this TRB training, maybe we can start the MEP services software, TME training. So is that clear now? So any doubt for anybody?
No, sir.
Okay. So tomorrow I will show you how to directly input the rebars into the existing 3D model. So shall we close the meeting? You please practice everything, whatever I have done. So I will share today's videos also. So if you have any queries, you please come out with the queries. We will clarify.
Okay, sir. Okay, thank you.
Yeah, okay. Thank you, all. Thank you. Bye.